That's okay. Everyone just be quiet though so I can, everyone that wants to listen can listen, okay? All right, so this is 9a, this is 3.4, this is 9a. Without using technology, sketch the graph of each function, label all intercepts. Okay, so all intercepts is x-intercepts and y-intercept. There's always going to be just one y-intercept, okay, because it's a function, f of x. Now, is this frozen? Sorry, okay, there you go. So this is the one we're going to do, and we're going to do it right from scratch. So it's a polynomial function, and I want to factor this, okay, boys? So this actually, the first thing you can do is notice that there's an x in each term. So I'm going to take an x out as the first factor. See that? This is going to leave me with x cubed minus 4x squared plus x plus 6. So that's the first step. Now you get that polynomial degree down 1 by doing that. So now I'm going to focus on this one, and I'm going to test using the remainder theorem. I'm going to test a values of plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Now I'm probably going to find a factor before I get to 6, but let's just try. So f of, let's say 1. What's that? That's 1 times 1 minus 4 plus 1 plus 6. So what is this? Does this look like 0? Negative 4 plus 7 plus 8. That doesn't look like 1, does it? What about if I change it to negative 1? What about negative 1? So this is going to be, I'm focused on this one being 0, right? So that's negative 1. This is going to be still minus 4. This is going to be minus 1 plus 6. So that's 5. Negative 6 plus 6 is 0. Look at this. Negative 1 gives me 0. Is everyone okay with that? Yep. All right. So that means that x plus 1 is a factor. That's a factor of this x cubed polynomial. Let's test it. Let's make sure. We might have made a mistake. Let's make sure. Synthetic division, I'm going to take my a value, that's negative 1, that I put in there. I'm going to take the coefficients that are listed here and cubed, squared, to the power of 1, to the power of 0. They're all accounted for. 1, negative 4, 1, 6. I'm looking for the remainder. So I drop the 1, multiply, put the product up there, add negative 5, multiply, that's positive 5. I add 6, multiply, put that up there, add 0. See how that is good? And things are just randomly disappearing. Love that. Okay. So, guys, if you're not paying attention to this, you're working on something else totally great, just don't talk, please. Just trying to talk. So I've got x plus 1 as a factor. I've also got, because this was an x cubed term, this is going to be x squared. X squared minus 5x plus 6. Okay? Is that a good second step there? Now, you're looking at this, and this is a quadratic. You could probably factor this by sight, and we certainly can. So my computer is crashing on me today. That's wonderful.
Love that.
Okay. So this is x squared minus 5x plus 6, as I mentioned. So if we factor this by sight, we've got x minus 3 times x minus 2. And there we go. Go away. So this is completely factored. Yep.
There's the x that was factored.
Yes, thank you. Don't want to forget about the x. That one was the first one we drew out. Beautiful. That's exactly right. So now that we've got a list of all the possible factors, now we can do our sketching. So what we need to know is the leading coefficient of the polynomial, which is positive, right? It's positive. It's also degree 4. So I know that the end behavior so the end behavior is going to be 2 and 1 up here. Somewhere. Okay, that's the end behavior because, again, positive leading coefficient, it's degree 4. So it's like this, right? Now, these give me the intercepts, right? So at 0, there's going to be 1. At -1, there's going to be 1. At +2, there's going to be 1. And +3, there's going to be 1. So I know that in the, now they're all multiplicity 1 too, I guess, right? There's no repeats for the factors. So if they're all multiplicity 1, they all just cross the x-axis. They don't come down and dip down, touch it, and go back up. They don't come down, dip down, touch it, and continue across. It's all just a straight cross. So I'm going to now adjust this end behavior to here. Okay, watching. So somehow, some smooth curve, okay, try and connect it smoothly. You don't know exactly how far it goes down. You don't know that yet.
Good morning, Grizzly fans.
So you don't know how low it goes. You don't know how high it goes in between 0 and 2, but you know that it has to go up and then come back down and pass through 2. You don't know how low it goes, and we'll wait till calculus next year to find that out exactly. So you'll be able to find that out exactly, how low it goes, what the shape is exactly, where it switches from concave down to concave up. All that cool stuff, calculus will give us the hint there. So the x-intercepts it asked for, so x equals -1, 0, 2, and 3. The y-intercept, that's y equals 0. Okay? Now, technically, technically intercepts are points, so you should have -1, 0, 0, 0, and so on. So 2, 0, 3, 0. So you should get used to writing them as points. And then, of course, the y-intercept is 0, 0. And then this is your rough sketch. Okay, so it should look like that. If you check this on your graphing calculator, it should look like this. I don't think we've missed anything. Notice that the end behavior matches up with all of the crosses, right? If you have something like this, if you said, oh, I've got another one here, and you got to do this, but your end behavior is up here, you're like, whoa, wait, what? So you got to double check, so something's not right. Okay? So, but as it stands, that's your graph there. Okay. Any other problems you guys are coming across here in your review? Nope.